Okay, here is another example of solving differential equations using separation. I think I'll be able to get through two really quick because they're pretty straightforward. So the whole purpose of separation is basically to get everything with an x on one side and everything with a y on the other side. So as you can see, this one is relatively straightforward. Uh-oh, there goes my light. We want to we're going to multiply by dy dx and divide by 1 plus x squared, and then divide by both sides by 1 plus y squared. So let's just go ahead and do that. You get 1 over 1 plus y squared dy equals 1 over 1 plus x squared dx. And now we simply want to just take the integral of each side, since everything's of the same variable, nice and straightforward. And if you recall, this is actually the the integral of this is arctan of x. And since this is the same setup in just y, it's the same thing. It's arctan y equals arctan x. Add your plus c on this side, because technically there's a plus c on either side, but since it's an arbitrary constant, if you subtract the c over here, it would basically be plus c1 plus c2, and when you take c2 minus c1, you could call it c3. I'm just calling it c, generic c. Okay, so there's our first one. Let's scoot on up to the next one. Let's write this out here. Okay, x squared plus 1 tangent of y prime equals x. Okay, so this looks a little ugly, but actually I take that back. While this looks ugly over here, since all this is multiplied, it's really easy to just divide by x. Divide by x squared plus 1. So let's do that. Let's take tangent of y, and I'll put y prime out here so it's not confusing, equals x over x squared plus 1. So once again, everything's on the same side. Oh, I apologize. Y prime equals dy dx. So you multiply, since this is dy dx, there's a dy here, you multiply dx on this side. And now you've got everything set up and you can integrate. Okay, so my particular professor really likes doing the integral of tangent because it's not terribly difficult to figure out if you just go through the steps with splitting it up into sine and cosine, and you can use substitution, I believe. It's been a while since I've done that. I just memorized that the integral of tangent of y is simply negative ln absolute value of cosine y. So I'm just going to go ahead and write that down. Over here, we want to do a, let's just break it over. We want to do a u substitution, so let u equal everything in the denominator. Oops, sorry, x squared, getting ahead of myself. So then du equals 2x dx. And we just so happen to have an x on top, so in order to make, we've got x dx left over. This is 2 times that. So therefore 1/2 du equals x dx. Okay, so let's pull the 1/2 out in front. X dx is now du, and then this is just 1 over u. So let's start rewriting our terms. We get 1/2 ln u plus c. Once again, the same thing earlier, generic c. And then we can get a final answer of subbing back in for what u is, which is up here. x squared plus 1 plus c. Alright, there we go.